Welcome back to Recursive Engineering. Today problem is maximize the cut segments. Given an integer n denoting the length of line segment. Okay, a line segment is given and its length is given as n, and you need to cut the line segment in such a way that cut length of a line segment each time is either x, y or z. Okay, our cut segments are given to us, and using these cut segments we have to form this line segment n is equal to 4 in such a way that whatever the segments we are taking, you should complete this n is equal to 4. Okay, after performing all the cut operation, your total number of cut segments must be maximum. Okay, you have to cut n is equal to 4 in such a way that whatever you are the segments you are taking, it should be maximum cuts you have to take to complete this n is equal to 4. And let's try to visualize this. The n is given to us, let's say 4. This is n is equal to 4 of line segment. X, y and z is given. 2, 1 and 1. Okay, we have to use these line cut segments to form this line segment. Let's take x of length 2 and y and y. So I am taking 3 cuts, and in this way I am able to make this n is equal to 4. You can try any possible way, like I can take y, x or z. X and y, z and y are of length 1 and x is of length 2, and we are able to make this n is equal to 4. And these are 3 cuts. What I can say, take 4 cuts of either y or z. I'm taking y and I'm taking 4 cuts, and if you look all the possible way, my 4 is the maximum one because it is of length 1, and I know if for n is equal to 4, this is my max. You can take y or z in either way because these are both are of length 1. So this is the problem. Can you guys think of a way where we will try all the possible combinations, and whoever have the max, we will return that, and we know we can try recursive approach here. Let's think. If my n is equal to 4, what I will do, I will subtract it with x, y and z. I have 2, and if I subtract it with y, I will get 3, and again if I subtract it with z, I will have 3. Okay, again I will further divide it with x, y and z because I have to try all the possible combination. So let's see. I will get 0. We'll divide it with y, I will have 1. I will divide it with z, I will have 1. Again I will subtract these with x, y and z. Subtract it with x, I have minus 1. I will subtract it with y, I have 0, and z, I have 0. So if I am getting this 0, it does mean that I am taking those cut segments for which my n is complete, right? Because if I am taking x and again x is of length 2 times x I am taking, so my n is equal to 4 length complete. So if I'm getting 0, can I say there might be possibility that it could be my answer? So let's return 1 here. Whenever I backtrack, I will return 1, and whenever I'm getting this negative integer, I will return a 0 because this minus 1 is exceeding my this n is equal to 4 length, and I know there is no possibility. And whenever I backtrack, I will take max of these 3, and I will add +1 in my max, because why I'm adding +1, because I have to take this current segment also, and whenever I am returning, I will take max of 3 and I will add +1. And why I'm doing this, because I have to find the longest branch. I know that whoever is the longest branch is my answer, because there are my maximum cut segments, and I have to find that branch which will give me 0, the longest branch. So this is my approach, but there is a case. Let's see that case. Let's say if my n is equal to 4, and I have my x, y and z as 3, and whenever I am subtracting it with x, y and z, getting 1, 1 and 1, and again if I subtract it with x, y and z, I will have my negative. Okay, so in these three cases I am getting this negative integer, but I cannot say like please return 0 and add +1 in my max, because there is no max. If you guys look at, there is no 0 I have in my any possible way. So I can say that if I do not have any max, please continue returning 0, because at the end I have to return 0, because for this n is equal to 4, if you try in any possible way, you cannot make this n is equal to 4. You can try taking 2 times 3, or 1 times 3, or 3 times 3. In either way you can try, you are not able to make this n is equal to 4. So I have to continue returning 0. And how I know that? I will see that if my max is 0, please continue returning 0. So this is the case. Let's write code now. I have a function max cuts, and I have arguments x, y and z, and I have to return this function, and I have to define function which have return type int max cuts. I have parameter as n, x, y and z. If my n is less than this, sorry, if my n is negative integer, please return 0, and if my n is 0, there might be possibility that I have my answer. And I have to take max of 3, so I will save it in a variable. Let's say x max is, make a recursive call and subtract this x with n, state is z and y. Just take a variable and store my max. And if I have my max as 0, please continue returning 0, or otherwise please return value +1. Let's try to see. Will it run or not? Yes, try for different case. It's not returning. Why? Okay, to return one here. Sorry, set max. I'm returning 3y. Okay. Whenever I am taking backtrack, I am adding plus one, and for this last case I am still adding +1, so it should not be like that. I have to subtract it with -1. And because if suppose if I am having 0 here for this last call, I cannot return -1. So to remove this underflow condition, I have to take 0. And let's try now. I hope it works now. Yes. Yes. Let's try to submit. It is showing time limit exceeded. We have to think for a better approach here. Okay. Can you guys think for a solution where we can use previous calculated values to calculate new ones and use that to return answer? What I'm saying, like, suppose here is 3, right? If you branch it down, and I know that it will return 4 because I'm having this one, and when you're going down you will have your max 4. But I know that for this 3 I am having the same branching as this 3, and my answer will return as 4. So can I use this previous calculated values to directly return 4 here? What I will do, I will take DP memoization technique. In this technique you will take an array, and whenever you have a unique value, unique n, you will store that max in that n. Like for this 3, I will store my max as 4, and whenever my 3 comes again, I will directly return 4 because I know this 3 is duplicate, and whenever my duplicate come, I will return directly 4. So I will take a memo array, right? So let's try to write code this for this approach. Let's take a DP array. It should be of length n plus 1. I'm taking DP. And I will say that if I have my max for this n, so directly return that in my this DP array. And if it is unique, then we cannot write here. Actually we have to write here DP of n should be my value plus 1, and we have to return that. We are storing this and returning this. Let's try to run now. Sorry, I am not past TP here actually. This working. Yes, it is working. I am doing something wrong. Okay, to return for DP of n, not n. So I submit this code. And yes, this is working. Let's discuss time complexity now. For this recursive approach, I know every time I am branching into 3, I know for this level I have 3 raised to power 1, and every time I'm branching into 3, I know for this I have 3 raised to power 2, and till I go for 3 raised to power n. So my time complexity will be big of 3 raised to power n, and my space complexity for this recursive approach will be, suppose if I am having this 1, so I will continue branch down until n, this nth level. I can say this should be my big of n, my space complexity. It is taking this big of n recursive stack, and for this optimal solution, which we are using DP memoization, our time complexity will be big of n, because I'm storing unique value, and whenever the duplicate come, I will directly return that. So my time complexity will be big of n, and space complexity, it should be same as this. It should be big of n. If you find this video helpful, please like and subscribe. Thank you.